Railway Conversations with Dr. Frank.
Hello and welcome back to the show. My guest today is Thomas Laux from Berlin in Germany. We talk about the Digitale Schiene Deutschland program, in English Digital Rail Germany, where Thomas has a leading role as being responsible for the development and introduction of future technologies. It's a very interesting program which I hope can be used as blueprint for other countries as well who want to modernize their railway systems. And I hope you do enjoy this episode. If you do, please subscribe and share it with a friend or two. Thank you. Hi, this is Dr. Frank again. I need to tell you about my brand new online ETCS training. It's the online version of the well-proven ETCS Kickstarter live training that has helped more than 200 railway professionals in Australia and New Zealand, regardless of their prior knowledge of signaling. So that really means you can learn the fundamentals of the European train control system, even if you didn't have any signaling knowledge before the training. How good is that? There's an online study group for networking during the training, and I also provide an industry-leading support of questions and answers, not just during your training, but also for a guaranteed minimum of 12 months after the training. Sign up now at docfranktraining.podia.com/ETCS. That's docfranktraining.podia.com/ETCS. Thomas, welcome to the show.
Frank, thank you. Pleasure to be here.
I was very much looking forward to that. I'm a big fan and quite fascinated what's been happening in Germany recently under the label Digitale Schiene Deutschland. In English, that's Digital Rail Germany. But I got the information that the DB wants to have this run under the German name, under the German label. So we just call it DSD for the further run of this conversation. Why don't you start telling us a little bit about this program and your role in this program, please?
So DSD is a program within Germany, as I said, initiated by Deutsche Bahn, which aims to bring digital technologies and automatization to the railway operations in Germany, and then by European standardization to Europe as well. And my role within the program is basically I'm the head of a department which focuses on the second part of DSD, which I guess I'll tell you about in the next minutes, aiming to bring digital technologies as in AI-based automated planning and dispatching, automated driving, and the next generation of our CCS, so command and control systems, to the railway operations in Germany and Europe.
Okay, well, we will certainly talk a lot more about that, but you mentioned there were two stages in the DSD program, and I got my attention came to that program from the first stage, actually, because I'm coming from a signaling background. When I was still in Germany, I did a lot of work on ETCS, European Train Control System, and Germany always had kind of a reputation of like dragging their heels a bit on ETCS. So other countries were much faster in rolling out ETCS. But now it seems that with DSD, ETCS seems to get a new boost. I'm not sure to what extent you can talk about that, but what happened, or how did it come that DSD put so much focus and so much drive behind ETCS?
Well, there's several reasons, actually. Technical reasons, commercial reasons, and legal reasons, of course. as you know, ETCS has been made mandatory for new and re-equipped tracks in Europe. So this is the legal reason, and there's it's mandatory to equip certain tracks, which is called the TEN network, Trans-European network, in Germany and in Europe with ETCS to have some a certain level of interoperability within Europe. And we have the technical reason that our legacy or our current control systems are becoming out of date. As you know, we have the PZB, so the intermittent control system in Germany, or train protection system, and the LZB, the continuous train protection system. The LZB system has been announced to be discontinued by our manufacturers in the 2030 years. So we need the next generation of train protection, and the PZB is well, it's a good system, but it's not up to the task for high-speed trains and for very highly utilized tracks in the network. So there's the technical reason to employ ETCS as the new standard command and control system within Germany. And of course, it's the basis for us for the future technologies that I'm responsible for. So it's the basis for automated driving, ATO. Automated driving goes together with the automated planning by our CTMS system, or capacity and traffic management system. We are utilizing ETCS in our next generation of CCS in order to get even more capacity, even more trains on the same tracks.
Yeah, you mentioned already automatic train operation, which is a feature, or say an add-on to ETCS, which only came out very recently with the last version of the ETCS standards, which came out in August last year, baseline 4. My suspicion why ETCS previously didn't get so much traction in Germany was that you had fully functioning existing legacy systems. You mentioned LZB for high-speed lines, and LZB underwent improvements such as SIL-Elke, which I don't need to explain too much for the listeners, but it's enough to say that you did have a continuous train protection system for high-speed lines, which was fully functional, which was optimized for the requirements of German rail, and which worked very well, and which was still functioning and not aged, not outdated, and so on. And to a similar extent, you had PZB for intermittent train protection for the conventional rail network. And again, it was a functioning system that did everything that German rail needed. The other reason, I think, was that ETCS at the time only provided another form of automatic train protection. So you basically would have replaced the fully functioning existing legacy system with ETCS without getting any functional gains, without getting anything in addition. Not even very much of a safety improvement for that matter. Whereas now it seems that you're using additional benefits, additional features of ETCS as a basis for the digitalization of your entire network. Is that kind of a right assessment or a correct summary?
I believe that's correct. Yeah, that's what I meant by economic reasons. You see, when you have a fully functioning and optimized, as you said, system working in Germany, it's not very economically viable to just tear it out and replace it with another system, which, by the way, was still or is still under development in Europe and under standardization. So while we have been working like behind the scenes on ETCS for quite a while now, I believe for nearly 20 years,
yes.
Still the decision to roll out ETCS was made in 2015. And now it's gaining more and more traction and more speed to get the rollout in Germany. And yeah, it's true. We're using that standard technology and a standardized platform to have like a standard basis for further digitalization in Germany for the further applications that I mentioned earlier, to have that going together with the digital interlockings or the rollout of the digital interlockings, doing the same on the interlocking side.
I was just coming to that. I think that's really an important difference if you compare where you are now in Germany compared to where you were, I don't know, 10 years, 15 years ago. Because 10 or 15 years ago, the task would have been to overlay ETCS level 2 on existing interlockings. Whereas now you're introducing a new generation of interlockings. You mentioned digital interlockings, that together with ETCS level 2, especially level 2 without signals, really provides operational benefits, or it can provide operational benefits to DB. And by doing so, creating a viable business case that just wasn't there like 15 years ago or 20 years ago.
There's actually an additional side or yet another side to this. As you know, we have interlockings from the 1890 years. So our oldest interlocking in Germany is from, I believe, 1894. So we have really a potpourri of different interlockings in Germany, and the rollout of digital interlockings, which of course works well with ETCS level 2, kind of gives us the basis on this side of the interlocking side to replace old technology, to replace different technology that's becoming hard to maintain and so on. So basically, we're running a full-on digitalization program right now in Germany, not only, but especially focused on interlockings and train control.
Yes, yes. And I mean, what you can do now, once you've got a technology platform that really proves beneficial, not just by replacing old equipment, but also by giving you the potential for operational benefits like more capacity or higher reliability or higher punctuality of the services. Yes. Then you can basically go back and say, okay, well, for a rollout in Germany across the entire national network over the next 10 or 12 years, what is a sensible sequence? Where are the areas that require replacement first? Or where are the corridors that have the highest priority? And right. On that basis, prioritizing those areas with the biggest need or with the biggest benefit, because you've got aging equipment, maybe that's failing more often than not. And now you're replacing this with the latest and greatest, and especially with a technology platform that will be coherent across the entire network. I think that's a huge benefit.
I believe so too. That's exactly the underlying reason or the motive for doing so. In addition to giving us the platform to introduce even more digitalization, as I mentioned before, in the coming years in Germany and Europe. In the end, we will have a modernized interlocking landscape, a modernized control system, which is standardized across Europe, and then additional technology, which we also can standardize across Europe.
I was interested how critical FRMCS is for your vision. And but I did see in one of the papers that the intent was to start rolling out FRMCS from 2028, roughly. So, yes. Yeah, well, maybe it's again, not too critical that I forgot it. Yeah.
There's a lot of reasons. First of all, GSMR is going out of service in 2035, I believe. So we have to have a new system. And then certain parts, not all of it, but certain parts probably will utilize or will need to utilize FRMCS because the current bandwidth is not enough anymore. Basically, that's the fallback or part of the fallback option for GA4. So part of the fallback option for fully automated driving is having some remote driver just remote controlling the train.
Yeah. Yeah, and GSMR. I mean, GSMR has always been a capacity constraint for ETCS level 2. And is the moment you want to start implementing this in high capacity areas, you've got to do something with your radio system. You can't be limited. You can't have the number of trains limited by the number of radio channels that you have. That just,
No.
yeah,
Yes,
well,
you can't.
yeah, which I think was one of the other reasons why it took so long to really get going with ETCS level 2. Yeah, so I was suspecting for a long time that there was simply not a business case. Yeah, so there was no chance to go for a level 2 without signals capacity increase as long as you are bound by GSMR radio. Before we come to the future improvements that will build on that technology platform that we just talked about, ETCS level 2 without signals and digital interlockings, you just mentioned control systems. Deutsche Bahn already had, I think, a quite sophisticated system of control centers where you had a relatively small number of centralized controls across Germany to control the entire core network of Germany. I'm talking about the Betriebszentralen. Um, how much did you change or improve this, or what did you change, if anything, in those centralized control area controls with the introduction of ETCS level 2 without signals and digital interlockings? Are the control standards still the same, or have there been changes to accommodate this new digital platform?
Well, there is a new strategy for our for the human control side, so to say, or for the operational side, still being developed and implemented right now. So I can't go too much into that. But I think it's fair to say that the main changes will be like under the hood. So the main changes will be like on the technology side. We will have some. It's called Technikstandort in German. So it's a center where all the technology is being hosted and also going to be distributed across Germany. And then the operational side, where the humans interact with the system, is not going to change that much as one might think, actually.
Yeah, yeah. Yeah, and that's mainly because you already had some quite sophisticated features, I think, previously in your operation control centers. So things, for example, like conflict resolution, where two trains are basically heading towards the same point, and instead of just having one train stopping and waiting until the other train is gone, you basically have systems that can see that the two trains will meet, and they can basically come up with early countermeasures to basically slow one train down, speed one train up, and avoid this conflict in the first place. So you've had this already, and I think
that's true. Yeah, even it's not been like standardized across the whole landscape. We have those technologies kind of on a pilot or a prototype level. It's not been implemented like on the whole system. And that's what we're working towards right now. Not only conflict resolution between two trains, but as our network is quite complex and quite big, as you know, you need to have a look further. What does it mean if one train runs a bit late? What does it mean like further down the line in 2 hours in the next city, in the next node, and so on and so on. So that's what we're working right now with the CTMS system, the aforementioned capacity and traffic management system, to have that kind of optimization and automated optimization actually implemented as a standard in Germany.
There's one more technology component which you consider part of your stage 1 in the DSD program, and that's automatic train operation in grade of automation 2. That means it's right. A support for the drivers. You still have a driver in the train cab, but the driving itself with automatic train operation would be done automatically. So the acceleration of the trains, the braking of the trains coming into a station would be all automatic. Now, you did mention in a previous answer that the ETCS standards are still evolving. And I think that's a very fair comment. We've seen various different baselines over the last 20, 25 years. Now, ATO was a very recent addition to the ETCS standards. Officially, it was endorsed in August last year. However, in Germany, I believe you have tested or piloted ATO already earlier. I believe in Hamburg, if I'm not mistaken. So my question here is, how do you ensure that you kind of align your existing ATO activities with the European standards that you now have for the last 9 months or so? But in having said that, once these standards are ratified, it doesn't mean that the supply industry immediately has products that are fully compliant. So how do you do that? How do you make sure that over time your already existing ATO activities will come together and align with the European standards?
Yeah, let me give a bit of a piece of information as a background first. First of all, ATO, of course, is not a really new concept. ATO has been around for I don't know 20 years now. It's not been officially standardized, as you just said. That's happened on a European level in the TSI CCS in last year. But like the concept and actually the technology has been around for quite a while, at least for ATO GA2, which, as you said, is about the train driving, braking, and stopping automatically, and train driver still being in charge of the whole operation. That's one part of the one part that one must know to have a bit of background, and the other part is that of course we are part of Europe and part of the European standardization, and we're actually driving the European standardization. So it's not like it's just popping up and then we have to deal with it, but we are the ones that are a part of the group that's shaping the European standards. So when you refer to the first implementation of ATAJ2 in Germany, which happened at the S-Bahn, so the regional transport in Hamburg, we actually had in mind and knew what was to come in the TSI, what was to be the standard. So we implemented a system which was already nearly standard conform. And now there are some very small changes necessary, but still basically we had 95% were already there. Actually the case that the vehicle manufacturer, so the vehicle side, the ATO onboard unit, is already there. It's already developed. It's a product that you can buy off the shelf, basically. Not quite, but basically. And we are working right now on a general ATO center, which is the infrastructure side of the ATO system. So basically, we knew what was coming, and to answer your question, we knew what was coming, and then developed the system accordingly.
The draft specifications for ATO over ETCS were around for many years, and it was just a matter of time until they would be finalized and made official in the last baseline. Right. And I don't think ATO was a big was slowing down the standard. I think there were other reasons why it took until August last year that baseline 4 came out. And as you said, at least 95%, I probably would have estimated even more than 95% of the ATO specs were already there. Yeah, but then you only know the final version when you see the final version. Yeah, but as you said, if you worked as DB worked on developing that specification and working also with industry who wrote the specifications, I don't think there were many surprises in there, like last second changes that were significant or so. It's
I think that's a fair assessment.
Yeah. Okay. With that, what we have established, just to summarize where we came so far, we established that stage 1 of the DSD program in Germany basically has 3 technology components: ETCS level 2 without signals, digital interlocking, and the third one, which you may not have everywhere, only where you really require it, is automatic train operation, ATO over ETCS, in grade of automation 2, which means you still have a driver. Right. So that is stage 1. Now I think we come to where where you really are responsible for, which is stage 2, with all the modern stuff,
Yes.
to be built on top of that platform. So how does the stage 2 look like, and what components do you see coming first? Because there's a lot of elements from what I could see. I've done a bit of homework there, and thankfully I got some information from DB to get me some pre-reading into the topic. So what's the first improvement, technology improvement, that you see coming in that second stage of DSD?
Well, as I said earlier, the second stage comprises of 3 areas of technology, basically. One is the upgrade from GA2 to GA4, so ATO in fully automated driving, which means that there is no train driver on board. The big change, of course, is that we need to have some kind of obstacle detection system on board or around, but some kind of obstacle detection system, which we think should be on board to have the train driving without a driver. The second is what I mentioned under the name of CTMS, which is a fully automatic system able to react to changes within the timetable or react to operational occurrences, unusual situations, as we call it. And the third is the next generation of our command and control system, which we call ADI, Advanced Digital Infrastructure, which is about basically fundamentally changing the way that we have our command and control train protection systems work. Right now, as you know, they work basically from a trackside perspective, as we always call it. So you have the trackside laid out first, and you specify first where the train can run, and only and then you have the blocks, and the train can go into one block, fixed block system, as you might know. We have a fixed block system where only one train can be in one block, which is how we avoid, or how the system avoids train collisions. And in the future, we're working towards a moving block system where trains run in absolute braking distance. So basically, the distance is regulated based on the velocity of the concurrent trains, or the trains running after each other. The functions or the specification is nearly there on the DCS side. It's not there on the interlocking side, so we're working towards that, and we're working towards an integrated system where we don't have an interlocking on the one side and then an ETCS central on the other side, and those two have to work together. But we'll have an integrated what we call CCS central. So that's the 3 parts: automatic train operation in fully automatic driving, automated planning, and then then advanced digital infrastructure and advanced CCS. And to your question, what will come first? We are working concurrently on those 3, so it's not consecutively, but in parallel. And what I think we will see very soon in Germany is like small steps towards the automatic planning. For example, we're working towards, and we call it autopilot for interlockings, basically not having the need for a human setting the tracks or controlling the CCS according to some timetable, but having that step automated. And then in the next step, which will be around 2030, we will have that fully automated dispatching. So not the planning part, the timetabling part, but the changing of timetables reacting to operational occurrences. So this is going to be 2030. I think soon after 2031, around 2031, we will have the first fully automated, not driving on a main track, but driving from the depot to the first platform. So the fully automated starting up of the train and then driving to the first platform and driving back, of course. And also around 2030, we will have the first implementation or the first taking into service of a advanced digital infrastructure project where we'll show that that new technology or that new CCS technology in real operations in Germany.
There were a number of very interesting points that you just made that I want to unpack a little bit for the listeners that may not be that intimately familiar with signaling as maybe I am. One is automatic train operation in GOA4. This is something that's quite common in metros. It's almost a standard. Well, it's not a standard feature, but it is relatively common in railways that use communications-based train control, CBTC, which is a different signaling technology to ETCS.
Yes.
But ETCS, as I keep saying in my training courses and online appearances, in order to improve the performance of ETCS needs to become more and more similar to CBTC, because CBTC is the gold standard for performance of a signaling system. But GOA4 has a lot of consequences for the operational environment of a railway. So it's a very different thing whether you operate a metro in a tunnel system underground compared to an open air railway where you can have, I don't know, deer running across the track, and you may even have level crossings. I mean, not on your high-speed line. High-speed lines don't have level crossings because it would be safe. But on the conventional rail network, you definitely still have level crossings, and you can't just get rid of them all in a network with like 40,000 or 42,000, whatever many kilometers you have of network in Germany. So, and what you did say is when you start introducing GOA4, which means unattended train operation, it will be in a relative protected area, like getting a train out of the depot, coming to the first station platform, and then from there will probably be still a train driver on board, so that on the open corridor, at least for the time being, you will remain operating in GOA2. So with some sort of a human being in there that can watch out for obstacles, for anything unusual, and so on. But in the long term, I think this is just the first step, right? Yes. So I believe the end game probably is to have driverless and unattended operation on, well, everywhere on the entire network. So how optimistic are you, especially regarding the public perceptions of ghost trains that don't have a driver in the cab? That this is going to work, that this will be safe, that there will be no big headwind from the population saying, I don't really trust the system where there's no human being sitting in the train cab, and so on. How do you think you can approach this?
As you said, fully automated or unattended or driverless driving or train operation has been around for a while in metro systems, for example, or in underground systems. So it's not fully new to the public, I would believe. There's always been, when introducing those systems, there's been some kind of hesitancy, but as far as I know, those have been accepted. Those systems have been accepted quite readily and quite well after people got used to them. And actually, children love to stand in front and just look out in front, which is not always possible with train drivers. So I believe the public is ready to accept such driverless systems. Of course, it's a very different type of thing to have, as you said, an underground running fully automatically, which is basically encased on all sides, and you don't have any chance of obstacles going on the tracks. And the same on an open network where this is very much a problem. So we need that obstacle detection system, which we don't need in underground or metro settings. for example.
Yeah, yeah.
So on the technical side, this is very, very much different. But on what the public is going to see, I believe it's not going to be that much different from underground or metro systems. It's always just a vehicle running on tracks without a driver in front.
Yeah, yeah, yeah. I mean, public perceptions obviously could change the very moment you have an incident.
Of course, that's the case. So that's our responsibility to make sure that there is no incident. And as you said, we're starting with the automated train drive from the depot to the first platform, which is not on the main tracks, which has not as high speeds, and which gives us the possibility to implement such technology first, getting value for our customers, which are our ROMs, of course, or the railway undertakings, and trying out the technology before going to the main stage on the open track network. I don't believe that the whole of Germany or the whole track network will run automatically, because there's always going to be some cutoff point where it's not economically viable to do so. For example, if you run just one train, like one tourist train a day, that's probably always going to be with a train driver. But like the bulk of the network or the bulk of the trains will be run automatically at some point, I believe, and probably sooner than many people expect right now, because the technology is developing so fast in recent years.
What I think is, and that's my personal view, is that just ATO in Grade of Automation 2 will give you massive benefits.
Yes.
And I'm not so sure. I mean, it's almost like two different philosophies. I mean, I'm also specialized in like metro systems such as CBTC. So I know a bit that there's an almost philosophical discussion between two different camps. One saying, well, in order to get real ATO, it needs to be driverless. Otherwise, it's just I don't know, a compromise. And the other side, and I see myself more on that other side, saying, oh, wait a minute, rather than having no ATO at all, GOA2 could already give you the majority of the benefits, and it may be much, much easier to implement than a GOA3 or GOA4. And that would be a statement for metros, and I think that is even more applicable to an open air mainline network like yours. Yeah, so I think
I mean, in the end, this is going to be kind of a modular system anyway. So I've talked about the upgrade from GA2 to GA4 is mainly not all of it, but mainly the obstacle detection system. But of course, a GA4 train needs the ability to drive automatically, brake automatically, stop automatically, and so on. So basically, it's nearly not possible to design a GA4 system without having some kind of GA2 component in there. And then why not go there and implement GA2 first and get the benefits already from GA2? Because this is nearly off the shelf. This is nearly developed technology right now. We just need to implement it. And then having the GA4 step when the technology is ready, which is not right now. So that's the approach that we're following right now.
What I could imagine is that the most likely scenario for mainline railway that I would see is not so much a GOA4 in its clearest form, like having no service personnel on board at all. Because in your case, that would mean you don't have a conductor anymore. You have nobody checking the tickets. You will have service staff on your mainline trains anyway, at least on the passenger trains, right?
At least on the long distance trains, yeah. It might be a different case for metro services, actually.
Yes. That's correct. I was thinking of the long distance trains, the likes of the ICE trains and the intercities and so on. So for those trains, I would envisage something like a GOA3 or maybe a GOA 3.5, depending on who's controlling the doors, whether that's done by staff or whether it's done automatically. But I would see it probably still makes sense for you to retain some kind of service staff on board that in an emergency could actually go to the front of the train and drive the train manually via an emergency driving desk or something like that. Yeah. So and it takes quite a bit of the risk out that you would have in a GOA4 scenario, especially integrated mode. If something goes wrong and you need to rescue a train, that may be much easier if you have stuff on board that can actually do something, and you don't have to bring stuff to the train first before being able to do some handling. Yeah.
Yeah,
And for,
we're still developing our strategy for non-regular situations, as you just described.
yeah.
First of all, I also believe that on long distance trains, there's always going to be some kind of personnel on board. And if it then makes sense to have that personnel qualified on a technical side to be able to handle the train in case of non-regular situations, or if it makes sense to have some kind of emergency manager trackside, which is then going to be able to drive to the train within a short time frame, that's something that will be first of all still under consideration, and second, I believe it will be decided case by case. So if you're in a metro system where we have short ways and it's easy for some trackside person to go to the train in a short time period, it's, I believe, more likely that we have that kind of solution for non-regular situations. And when we're talking about long distance, it's probably more viable to have the personnel on train have some kind of additional qualification to handle the train in case of some emergency or some non-regular situation. Yeah.
This is the end of the first part of my conversation with Thomas Laux. If you liked it, make sure that you also watch the second part that will come out in a week from now on Thursday. Hi, this is Doc Frank. Let me jump in here right now to tell you about a new training which is called High Capacity Signaling Blueprint. This is a very unique all-in-one training that gives you everything you need to know about high-capacity signaling. The foundations, where you can compare what conventional signaling is to what high-capacity signaling is with all the necessary definitions. Then we look at CBTC, communications-based train control, as the prime technology for high-capacity signaling and how this is done. In the third part of the training, we look at varieties of the European Train Control System, ETCS, another global train control technology, and how this can be used to achieve high-capacity signaling. And then at the end of the training comes an actual blueprint how to apply CBTC or ETCS to get a real high-capacity outcome for your railway. It's basically 3 training courses in one, and as usual for my trainings, there is a study group available for joint learning with other people taking the same training. And after the training, you will get into an alumni community, which is exclusive for my training students, where you can ask questions and get them answered by myself on an ongoing basis for a guaranteed minimum of 12 months. You can sign up on my usual training platform, which is docfranktraining.podia.com/HCS Blueprint. I said it again, docfranktraining.podia.com/HCS Blueprint, with HCS being the acronym for High Capacity Signaling. If it's important for you to learn about the latest trend in railway signaling, which is high capacity signaling, then this is the training for you. Hi, it's Doc Frank again. I hope you liked today's episode. I like to keep it as simple as possible, so I only have one single request for you. If you like this podcast, please tell your friends and colleagues about it. That's all I want, because that's a service that I'm providing to the industry, and I would like as many people as possible to listen to this podcast and learn something from it. So please share. And until next time, keep it simple and bye for now. Thank you for listening.